Had a few people ask me about this, and I was planning on doing a piece of content around the Stratbox Nade Database anyway. It's still in the testing phase, obviously, but the overall concept is set, and it's really interesting. So I'm going to walk you through the backend. So essentially, this is how I control Counter-Strike 2 using Laravel. I'm going to go through the whole pipeline, not just the Counter-Strike 2 part, but I think that's the most sort of interesting bit about it. Stratbox, first of all, just if you're running across this, Stratbox, I bill it as like the ultimate CS2 toolbox. It's got a custom strat editor in it. It's got an existing Nade database, but it's manual, so you can upload your own screenshots and your own videos, but none of it's automated. There's a calendar and there's a demo vault just for cloud storage of your demos. It's meant for teams primarily, but I think this new Nade database can start to push us into a new era where just existing players can benefit from this tool. So the initial idea, this is a direct picture from my whiteboard, which is off to my right here, was to create just the most comprehensive library of Counter-Strike 2 utility ever. But by getting it from pro games, from professional matches, if a grenade is thrown a certain amount of times in a pro match, I want to know about it. I think it's cool. So to do this, we need to automate the entire process from downloading the demo file to recording it, passing out all the nades, all of that stuff. It needs to be a full pipeline. And this is sort of the culmination of about 3 or 4 months of work at this point, I believe. First of all, if you're not familiar what demo files are, Source Engine allows you to record demo files, which records everything that's going on in the game. You can then replay this in the client, which means you can fly around in the camera, you can watch individual players' point of views. It's basically a full-on reconstruction of everything that went on in that match. There are already libraries to parse this, such as Marcus WA's Demo Info CS and the Saul demo file library. That's Golang and then JavaScript and C#, respectively, there. But the first step, obviously, is research, and I need to figure out if anything like this already exists. Primarily the recording part of it. I know that the rest of it can be done. It's the actual automating of the recording that's a bit of a struggle, and also I don't know low-level languages like C++, so if I'm having to write stuff to inject into the game myself, I'm going to run into trouble. But it sort of does already exist. And by sort of, I mean pretty much exactly. So this guy Rooney had made a Discord bot that records matchmaking highlights. I saw this on Reddit a while ago, and when I first had this idea, that immediately popped back into my head. And the bloody legend made it open source, didn't he? So I could source dive. I don't use Python a lot, I'm not a big fan. But the whole thing's written in Python. It's readable. It's lovely. The code base is great. Counter-Strike can be remote controlled using something called Telnet, which is basically a remote console. Essentially, almost like SSHing into a box. Kind of. You just get remote access over a TCP socket. Then tools such as Half-Life Advanced Effects, which is primarily a movie-making tool, can be used to record the game at full quality directly to a video file. So that's that part done there. Just need to do all the rest of it, and I'm aware I've jumped ahead. HLTV is the only publicly accessible place that you can download all the pro demos from. It's behind Cloudflare. They don't really like you scraping it. I'm not going to go into too much detail. Essentially, I wrote a script using Bun in JavaScript and Puppeteer that downloads the demos for me and then stores them on my own cloud storage, so I don't have to keep bothering them every time I want a demo. I just need the demo. This is the only place I can get it. That's what you've got to do. Parsing the nade throws, I opted to go with Go because that's a language that I know. I basically just put all of these scripts that are using external languages in the root of my Laravel. There's obviously app and database and all that stuff. I made a new folder called lib, and inside all of those is the various different tools. So one for scraping, one for the nade extraction, that sort of thing. It's just a Go program, and it dumps JSON to the standard output, which an artisan command picks up, loops through, and PHP does all the interaction with the database. So what do we actually need to know from the demo file? Well, this is the list here. Where they're aiming, where they're standing, where the nade lands, what type of nade it is. Is it an incendiary? Is it a Molotov? And I'm so glad I split those two out, given the most recent update where the Molotov and the incendiary spread patterns have changed. Flashbang, HE, that sort of thing. I ignore decoys, don't need them. Whether the person's standing or crouching, middle left click or right click throw. So with the left click throw, for again those who aren't familiar with CS, left click throw is the furthest you can throw it. It's full strength. Right click is like dropping it essentially on the floor, and a middle click is somewhere in between. And also obviously what map it's on. That's very important, and I almost forgot to include that in the database. I caught it early on, luckily. A lot of this data is already available just in the game with the Demo Info CS Golang library. You can see the events there that I was using. You need to link the original throw with the destroy event, which is where the nade finishes, whether that's the smoke blooming or a HE exploding or a flashbang going off, that sort of thing, which is a little bit tricky. You have to go for the entity and use the unique IDs there, but it is possible. It's just a little bit of dev work. Next step is finding similar nades. This is done in PHP, so I've got an action which just runs a query, essentially returning a model. It's just comparing numbers. I have some thresholds defined for movement speed and aiming and the degree aim cone, that sort of thing. And if I find any other nades within that threshold, then that's one of the parent nades, essentially. So if I can follow the chain up to the original instance of that nade being thrown. Next step is recording the game. Now, I love React, just not the JavaScript framework. I like the PHP library, which adds a load of async stuff to PHP. It's great. It's so good. It saved me so much time. It's brilliant. I'd originally written all of the scripts to interact with the game in JavaScript when I was doing my initial sort of proof of concept, but I moved it all into PHP, which means everything lives in the same code base. It's all Laravel. It's all great. I love it. So I've got two classes, CS2, which controls the game, demo recorder, which is on top of the CS2 class, which handles the demo recording stuff. The CS2 class just abstracts the communication over Telnet, essentially. It uses the TCP connector in React PHP, and it's got three main methods. Execute, which throws a command into the TCP socket, doesn't care if it comes back or not. Ensure execute, which generates a random string, echoes that, then executes my command, and then sends the random string again. And so as soon as I detect that random string being sent the second time, I return, which basically blocks the function until I'm sure that that command is executed. And then wait for string, which blocks until a certain string is found in the code. So you can put that all together to detect state changes. This string here, for example, comes up in the console when you go to the main menu, which is great. So I can detect when the game's finished loading. Then I can tell the game to load a demo. Then there's another string, which is similar to that one for when you're in game, which means I can detect when the map has finished loading and I'm ready to record. I'm also, any time an exception happens, I just kill a game, kill a job, kill everything, start again. It's not worth trying to recover. It just isn't. It's easier to have your job retry, kill the game, start from scratch, because there's so many different things that can go wrong. It's not worth it. Automating the demo recording is really easy with HLAE as well. There's a command from HLAE called merv_cmd, which you can schedule essentially a bunch of commands to be executed at a given tick. Demos are 64 tick. There is 64 ticks frames of information per second. I figure out the tick when the nade is thrown. I go 64 times 5 back. That's when I want to start recording. And then 64 times 5 forward. So I get a 10-second window, 5 seconds before, 5 seconds after. You know, sometimes Valve throw a spanner in the works. For example, I woke up one morning and spec lock to account ID, which is what I was using to switch to a player based on their Steam ID, just disappeared. It just gone. But it turns out these two commands unlocked it. That's the tricky thing when you're working on a project, especially around a brand new game as well, as stuff's liable to change, and a lot of this stuff isn't commonly used, so the devs are much happier to break it if they want to. Then the final steps, HLAE will record the video to separate audio and video files. You just combine those with FFmpeg, and then you do another pass to bake a watermark in, so I can tell when somebody's stealing my videos, and then this is the final result. You can see 5 seconds before, 5 seconds after. So you get a bit of context. Obviously, you need a server to run this on unless you want to forego video games forever. So luckily, I still have the parts from my old gaming PC, which is an i5 and a GTX 970, which is more than enough to handle recording because HLAE ensures that you have whatever frame rate you set. So if I set it to 60 FPS, HLAE will guarantee I get 60 FPS. In my case, it's 720p 30 FPS. You don't need super high resolution. Most people playing don't even play on like 1080p. They'll be playing on 1280 by 960 or 800 by 600. I found that I probably needed to be able to run this in parallel a little bit. My brother's old computer had a GTX 1050 Ti in it, which I also have. And so then I used Proxmox virtual environment. I got this idea again from Rooney. That original Striker bot was running on Proxmox with Windows VMs. So I have two Windows 11 VMs. They have direct GPU access, so each one has access to one of those two GPUs. 36 gigs of RAM in the computer. I give each VM 10 gigs, and then the i5 has 6 cores. At the minute, each VM has 3 cores because I'm not using that machine for anything else. That's essentially it's a very high level, very quick overview of how this worked. Thank you very much for watching.